In this video, I'm going to demonstrate how to install a Cooper 200 amp low break elbow on a 1-aught compact copper tape shield EPR medium voltage cable. Some things to verify before you begin the installation of the termination is that you have a compatible termination for the cable that's being installed. You have a compatible shield adapter kit for the termination, and that you have the appropriate size lug as well as the dies for crimping the lug.
Just going over the actual apparatus we're going to be installing today. This is a Cooper 200 amp low break elbow with a capacitive test point. Comes standard with the probe insert tool, and a couple silicone packets. We have a 1-aught copper top with a threaded insert right there. You see it's got the threads in there, and that's actually what the probe itself is going to thread into once it's crimped onto the cable inside of the actual boot. And then we have a Cooper SA2 cold shrink kit with ground braid and drain wire, along with the constant force spring and the mastic that goes along with the SA2 kit. I'm just doing an overview of the tools that we're going to be using. So from left to right, this is actually a Ripley brand probe installation tool, which is the same tool as this. It's just this is actually a torque wrench, and you get a little bit better bite on it, and it'll actually snap. You know, it'll pop when it reaches the appropriate torque. This is a Speed System 1700 SS adjustable semicon score, and a Speed System 1542 CL 2CL adjustable insulation stripper, as well as a Speed Systems chamfering tool. Over here we've got a silver Sharpie. We're going to be marking all the cable with that. It shows up really well, better than a black Sharpie or an oil pen. And we're going to be using a stick rule. And this particular stick rule actually has a slider on it so we can measure the depth of our connector. These are constant force springs. This is actually a steel spring that has memory to it, just like the wristbands I used to get as a kid. And these come standard in ground kits, just like that. And just throughout the years, just any extra parts and pieces, these are really handy for doing cutbacks on cables. So if you run into those, I'd recommend just holding on to a couple. They'll come in handy, and I'll show you why. This is copper tape, and this comes in handy for doing a cutback on the tape shield cable, which we're using. So I'll show you what that's for here in a little bit. This is our PAT 750. This is a hydraulic crimper that we use on our termination end. Just some of the hand tools I'll be using is just a standard pair of needle nose pliers, and I actually have like a micro pair of needle nose pliers, which this is extremely handy for getting into some of the tighter spaces of the cable and making a pretty exact cut or rip or whatever you need to. This is a pair of duckbill pliers. I think Speed Systems makes a pair of these. These are actually channel locks, but these are really good for semicon cutbacks. Good pair of Klein ratchet cutters. And I wanted to point this out. This particular tool I'm not going to be using, but I did just want to highlight it. This is actually a PVC cutter, and what some guys in the field will use with it is actually for making the ring cut on the insulation. And I'm not a huge fan of using this tool because with a little bit of error you can squeeze too hard and actually cut through some of the delicate copper that's underneath. So I'm actually not going to be using that, but I just wanted to point that out. This is a shoe knife that we use, a typical splicer's knife. We use that very frequently. And then this is a Stanley, just basic Stanley 99 razor knife, retractable blade. I'll use this every once in a while. Some terminations dictate, just because of the build of the cable or different factors, that you almost have to use a razor knife. Some guys will actually perform the entire splice with a razor knife. I prefer to use the specialty tools to do that. It's just a little less risk factor. Not saying you can't do it with a razor knife. It just takes a lot of knife practice, and it's very easy to mess up if you don't have the appropriate practice. So, but we may end up using this, we may not. And then moving over here to our cleaner. This is a power saw. It's a high voltage degreaser cleaner. We'll be using that to clean our cables. This is a lint-free wipe. It's a 10 inch by 10 inch wipe. And then we have 120 grit aluminum oxide sanding cloth. And that's a summary of all the tools we're going to be using for the particular kit. This is the cable we're going to be using. This is actually a 1-aught compact copper EPR, or ethylene propylene rubber, copper tape shield cable. The cable itself is one size smaller than what it actually is. So if I say it's a 1-aught compact, it's actually the same size as a number 1 compressed cable. So all your terminations, so like this copper top for instance, this isn't a 1-aught copper top, but it's actually a number 1 stranded copper top. So just something to keep in mind, the difference between a compact cable and a compressed cable.
So our first step is determining what our jacket cutback length is going to be. This particular set of instructions is for a jacketed concentric neutral cable. So on the left hand side you can see the cutback is 8 to 8.5 inches, which we would take the 8.5 inches. Well, we have to compensate for our tape shield cable, so going to our SA2 instructions, it needs a minimum of 1 1/4 inches to make the connection to the ground braid. So we'd add the 1 1/4 inches to our 8.5 and come up with a 9 3/4 cutback. We'll go ahead and mark that on our cable and make our ring cut. The next cut made is the longitudinal outer jacket cut. It goes from the ring cut to the end of the cable. You need to be careful not to apply too much pressure to damage the underlying layers. Once the longitudinal cut is made, the duckbill pliers are used to separate the outer jacket and remove the outer jacket. I apply a piece of vinyl tape to the end of the tape shield as not to allow the copper tape shield to unravel. I will then measure out the copper tape shield cutback length and then apply a piece of copper tape with the leading edge on the mark I've made. I will then apply a constant force spring to the leading edge of the copper tape. This will allow me to pull back the copper tape and tear against the constant force spring. I'll now remove the copper tape shield. There's 2 pieces of copper tape shield, so I'll do this both at the same time. I begin wiggling back using force against the constant force spring and tearing in a diagonal fashion and around the cable. This will leave a clean factory edge, and you do not have to use any cutting tools to do so. I will now remove the constant force spring. Because I put the copper tape on top of the copper tape shield, I can remove the constant force spring without unraveling the copper tape shield. I'll then take my shoe knife with the blade pointed towards the copper tape shield and flatten out any sharp edges. I'll now perform the insulation cutback. According to the instructions, the cutback length is 2 1/8 inches. I'll take my insulation stripping tool, set the blade depth as well as the cutback length to 2 1/8 inches, and perform a practice cut backwards as to not cut into the cable to verify that the blade depth will not penetrate through the insulation into the copper. Using the chamfer tool, I will now install an 1/8 inch bevel on the end of the cable. I'll now install the copper top and crimp with the Burndy high press. I'll now measure the semicon cutback. You must measure from the crimped copper top to the semicon to ensure that when the boot is installed, the internal semicon layer will line up with your semicon cutback. Using the semicon scoring tool, I'll make the initial square cut, then switch the tool over to spiral cut and spiral to the end of the cable, removing the tool. It's good practice to do a test cut with your semicon score on a scrap piece of cable or the very end of the cable to ensure that the blade depth is not too deep and will cut into the insulation below. Using the duckbill pliers, I begin peeling back the semicon layer. Using the 120 grit sandcloth, I will now sand the cable evenly on all sides. I will now nest the cold shrink tube before I clean the cable and install the termination. Using cleaner and a wipe, I begin at the end of the cable and work my way back to the semiconductive layer. I'll now apply silicone grease to ease the installation of the termination. I'll now install the 200 amp elbow. Before installing, ensure there are no sharp edges or burrs on the copper top. Install the 200 amp elbow facing the same direction as the threaded end of the copper top and push down until the copper top is seated fully inside of the 200 amp elbow. Now install the probe. Align the 200 amp elbow with the threaded end of the copper top and install the probe by hand until snug. Make final torque with an appropriate probe insert torque tool or use the factory supplied torque wrench. If using the factory supplied torque wrench, you will turn the torque wrench until the bar is bent. Wipe off any excess silicone grease from the elbow installation. Align the supplied ground braid in the SA2 kit onto the cable, mark and cut as to not let the ground braid overlap. Install the ground braid directly onto the ground tape shield. Ensure that the ground braid does not overlap and secure with a constant force spring and a wrap of copper tape. Install the ceiling mastic. The ceiling mastic will be installed on the end of the 200 amp boot as well as the end of the cable jacket. One wrap needs to be installed underneath of the ground braid under the solder block, and another wrap installed over top of the ground braid over the solder block. Secure and protect your ceiling mastic from the cold shrink tube with one wrap of vinyl tape. Install the cold shrink tube beginning on the leading edge of the 200 amp boot ceiling mastic. Finally, install the static ground onto the back of the boot, twist the wire, and trim off excess. This is a completed Cooper 200 amp low break elbow.